If I asked you what the most powerful and destructive thing in the universe is, most of you would probably answer black holes. And honestly, that wouldn't be wrong. Even though black holes are extremely small, they can destroy objects much larger than themselves. They can even swallow them entirely. So what makes these objects so powerful? Why is everything in the universe weaker than black holes? Today we're going to answer this question in great detail. If you enjoy this kind of content, don't forget to subscribe to my channel, like the video, and share your ideas for future videos in the comments. Now, if you're ready, let's jump right into it. First of all, we need to clarify something. Black holes, one of the most mysterious structures in the universe, are not simply a form of destruction. They are in fact the point where the laws of physics reach their absolute limits. Understanding what a black hole is doesn't just mean understanding a celestial object, it also means pushing the boundaries of space, time, and mass itself. The laws of physics that apply on Earth and throughout the universe seem to break down when it comes to black holes. We still don't fully understand what happens there, or how these laws evolve under such extreme conditions. However, thanks to our advancing technology and knowledge, we are able to make highly accurate predictions and develop strong theoretical models about these structures. In recent years, black holes have become one of the most intensively studied subjects in modern astrophysics. One of the main reasons for this is the possibility that they may hold secrets capable of advancing humanity by thousands of years. To understand the origin of black holes, we must first turn our attention to the life cycle of stars. This is because most of the black holes we know today are the result of the deaths of massive stars. The life of a star is shaped by its mass, and when a sufficiently massive star reaches the end of its life, it doesn't simply fade away. Instead, it ends in one of the most violent events known in the universe. I talked about this in detail in my previous video, but for those who haven't seen it, let me briefly go over it again. Throughout its life, a star maintains a balance between gravity pulling inward and pressure pushing outward. The nuclear fusion reactions occurring in its core convert hydrogen into helium, producing energy. This energy increases the internal pressure of the star, allowing it to resist gravitational collapse. However, as we know, no star has an unlimited supply of fuel. Eventually, it consumes all of its energy source. As the fusion process continues, heavier elements begin to form, and eventually the core reaches elements like iron. This is perhaps the most critical point of our video because iron cannot produce energy through fusion. As a result, energy production in the star's core drops to zero, and the internal pressure begins to decrease. After a while, gravity becomes unstoppable and the core suddenly starts collapsing inward. Contrary to what many might think, this collapse does not take a long time. It happens within seconds and causes the outer layers of the star to be violently expelled into space. This event is known as a supernova. After the supernova, the remaining core can transform into different structures depending on the star's initial mass. If the core is below a certain limit, it becomes a neutron star. However, if the core's mass exceeds a critical threshold, no force can stop the collapse anymore, and at that exact moment, a new black hole is born in the universe. When a black hole forms, all of the matter is compressed into an intihai small volume. This density becomes so extreme that nothing can withstand it. Even space-time itself cannot endure this density and begins to bend. At this boundary lies what is known as the point of no return, commonly referred to as the event horizon. Once anything crosses the event horizon, it can no longer escape. Let me emphasize something here. I'm not saying no object can escape. I'm saying nothing that we currently know can escape. Even light, which is considered impossible to surpass, cannot escape a black hole. That is exactly why these structures are called black. Since even light cannot escape, they cannot be directly observed. In fact, the circular glowing structure many people imagine is actually the event horizon itself. The black hole itself cannot be seen or imaged directly. It is impossible. The region believed to exist at the center of a black hole is called the singularity. A singularity is a point where the known laws of physics no longer apply. Density approaches infinity, and the curvature of space-time becomes limitless. This remains one of the biggest unsolved problems in physics, because quantum physics and general relativity begin to contradict each other at this point. This is where scientists become extremely confused. They cannot fully determine how to solve black holes or what exactly happens at that point. Since no physical laws clearly apply, they cannot predict how any form of matter would behave. For example, scientists cannot determine what would happen to even the most durable material known in the universe if it entered a black hole, or how it would behave. To give an exaggerated example, a material considered the most durable in the universe might be instantly destroyed upon entering a black hole, while another material that would normally disappear easily under Earth's conditions might somehow remain intact inside a black hole. Of course, this is an exaggerated scenario. In reality, no scientist believes that any object could remain intact inside a black hole. However, such examples are used to illustrate just how extreme, unpredictable, and seemingly impossible these objects are. Anyway, we now know that black holes are not formed only by the deaths of stars. There is also the theory of primordial black holes, which may have formed in the early universe shortly after the Big Bang. These black holes could have originated from density fluctuations, and some of them might still exist today. In addition to that, many galaxies contain supermassive black holes at their centers. Unfortunately, we still do not fully understand how these black holes formed or how they settled at the centers of galaxies. However, several theories have been proposed, such as the merging of smaller black holes, the collapse of massive gas clouds, or the direct formation of large structures. To truly understand the power of black holes, we must realize that they are not just objects that consume everything. On the contrary, by interacting with the matter around them, they create some of the most energetic events in the universe. Matter falling into a black hole reaches incredible speeds as it approaches the event horizon and heats up to millions of degrees due to friction. During this process, powerful X-rays are emitted. Based on this idea, science fiction enthusiasts have developed various theories. Some of these ideas have even been explored in legendary films like Interstellar. One of the most interesting theories suggests that humanity could one day develop advanced technology capable of absorbing the intense heat and powerful X-rays generated near a black hole's event horizon. According to this theory, a specially designed spacecraft could approach very close to the event horizon without ever crossing the point of no return. In doing so, it would accelerate to incredible speeds, potentially allowing it to travel distances in 5 years that would normally take 50 years. However, I have some bad news. This theory is not possible, neither according to the laws of physics nor with current or foreseeable technology, because in such an operation, the risks are not limited to heat and X-rays. As the spacecraft reaches such extreme speeds, it would be bombarded by an intense gyration of matter, and currently, there is no known material that could withstand such conditions. Additionally, we do not fully understand what the passengers inside the spacecraft would experience under such extreme conditions, nor do we have any effective way to protect them. There are also many other obstacles. For example, even the closest black hole is millions of kilometers away from us, and reaching it could require multiple human generations. This topic actually needs to be explored in much greater detail, as there are many more possibilities and challenges involved. I will cover this subject in depth in another video. But for now, you should understand that this theory will remain purely theoretical and will never become reality. It is something that can only exist in science fiction films. Anyway, returning to black holes. Some of them emit jets from their poles at speeds close to the speed of light. These jets can extend across intergalactic distances, showing that black holes are not only destructive, but also play a role in shaping the universe. The answer to why black holes are so powerful lies in the combination of mass and density. The gravitational strength of a black hole depends on its mass, but what makes it truly unique is that this mass is compressed into an extremely small volume. This creates an unbelievably strong gravitational field. For example, imagine compressing the mass of the Sun into a region just a few kilometers wide. In that case, a black hole would form, and due to its extreme density, the escape velocity would exceed even the speed of light. And that is exactly why nothing can escape from a black hole. Neutron stars are also objects where an enormous amount of mass is compressed into a very small hajm. You've probably heard the most popular example. A teaspoon of neutron star material would weigh more than Mount Everest. This gives you an idea of just how extreme these densities can be. Now, I want to shift the focus a bit to the black holes found at the centers of galaxies. There is no absolute rule that every galaxy must have a supermassive black hole at its center, but the vast majority of them, including our own galaxy, do. The black hole at the center of the Milky Way is called Sagittarius A star. This black hole has a mass of about 4 million suns. It is located approximately 26,000 light years away from Earth, and although it cannot be observed directly, its existence has been definitively proven by studying the motion of the stars around it. These stars orbit at incredible speeds around an invisible mass. in 2022, thanks to the Event Horizon Telescope project. The first image of this black hole was captured. However, as mentioned before, this image does not show the black hole itself, but rather the bending of light around it and the glowing ring of hot gas surrounding it. Sagittarius A star is currently a relatively quiet black hole, meaning it is not actively consuming large amounts of matter. However, this may not have always been the case. Some evidence suggests that the center of the Milky Way was much more active in the past. This also indicates that the black hole could become highly active again in the future. Up until now, I've been explaining black holes as if they belong to a single category, but understanding them this way is actually quite difficult. That's because black holes observed in the universe are classified into different types based on their formation processes and masses. This classification is not just about naming, it also provides important clues about how the universe has evolved. The first and most common type is the stellar mass black holes that I mentioned earlier. These black holes form from the collapse of massive stars after a supernova explosion. Their masses typically range from a few times the mass of the Sun to several Desatki times its mass. These types of black holes are quite common in galaxies and are often detected in binary star systems by pulling matter from nearby stars. The next category is intermediate mass black holes. These range from hundreds to thousands of solar masses. For a long time, they were only theoretical, and confirming them observationally was quite difficult. Today, some candidates have been identified, especially in globular star clusters. The formation of these black holes is still debated, but the most widely accepted explanations involve the merging of multiple stars or the gradual growth of smaller black holes over time. The largest, most impressive, and most powerful ones are supermassive black holes. These can reach millions or even billions of solar masses. Just think about that. Billions of suns. These types of black holes are found at the centers of nearly all large galaxies, including the one at the center of our own galaxy that we just discussed. However, there are even larger examples in the universe. At this point, a critical question arises. How did these enormous structures form in such a short time? Supermassive black holes have been observed even in the early stages of the universe. This cannot be fully explained by classical models of stellar evolution. That is why alternative models, such as the direct collapse theory, have been proposed. According to this model, massive gas clouds may have collapsed directly into black holes. In addition, black holes are not only characterized by their mass, but also by their rotation. When a black hole spins, it drags the space-time around it. This effect is known as frame dragging and is one of the key predictions of general relativity. Rotating black holes are called Kerr black holes, and in these structures, even the event horizon is not static. So, are black holes really completely black? For many years, with the development of modern astronomy, scientists believed that black holes did not emit any form of energy at all. However, in the 1970s, Stephen Hawking introduced a theory that completely changed this idea. According to Hawking, when quantum mechanics comes into play, black holes are not entirely black. Near the event horizon, pairs of virtual particles are constantly being formed. Normally, these particles annihilate each other, but if they form extremely close to the event horizon, one of the particles can fall into the black hole while the other escapes. The escaping particle appears as radiation to an outside observer, and this phenomenon is known as Hawking radiation. This process is extremely slow, but it is theoretically very important because it means that black holes can lose mass over time. In other words, black holes, which many people believe to be eternal, may not actually exist forever. At this point, a very critical question comes to mind. Based on this theory, can we say that a black hole can completely disappear? Theoretically, the answer is yes. Due to Hawking radiation, black holes can evaporate over extremely long timescales. However, these timescales are almost unimaginable. For example, a black hole with the mass of the Sun could take trillions of times longer than the current age of the universe to completely disappear. So while it is theoretically possible, in practice it becomes almost impossible. Additionally, as a black hole gets smaller, Hawking radiation increases. This means that in the final stages, the process could lead to a very rapid release of energy. According to some theories, this could result in a massive explosion. However, this process has not yet been directly observed. As I mentioned before, black holes still hold incredible mysteries, and there is still so much we do not fully understand about them. There are many more topics to cover about black holes, but I don't want this video to become too long and lose your interest. That's why I decided to split this video into 2 parts, and the next video will be a continuation of this topic. I hope you enjoyed the video video and got the experience you were looking for. If you did, don't forget to like the video, subscribe to the channel to support me, and share your ideas for future videos in the comments. Let me remind you one last time. This video will be a two-part series, and I will upload the second part in 3 days. In that video, I will talk about black hole mergers and theories such as wormholes that may be connected to black holes. That's all from me for now. See you in the next video. Take care of yourselves and goodbye.